Hello and welcome to the second session of our course, Machine Learning with Python. In our previous session, we understood what linear regression is and how to predict linear value using a linear regression line. In this session, we will extend ourselves to logistic regression and understand what this is all about. Contents that we are going to cover would be: what is the need of logistic regression? As we already have linear regression, why do we need a logistic regression line? So building a logistic regression line, and then we will find the goodness of fit measure for logistic regression line, which will allow us to understand if there are two models we have built with logistic regression models, which one is better. Then we will understand multicollinearity from the perspective of logistic regression, and we will also see individual impact of variables in a logistic regression model. Next, we will move to model selection, where we will learn how to select the best model if we have built more than one models. What is the need of non-linear regression line? Well, there has to be some other requirement or some other need to go to the non-linear regression line, because we already have linear regression line for us. Let's understand this by a simple example. We are going to take a product sales data that we have, which contains two variables, bought and age, and we will build a predictive model which would be a linear regression model, and we will check a few parameters of it, and then we will try to predict the values using the predict function. But the parameters that we have, or the variable that we have, are bought and age. Age is our predictor variable and bought is our predictive variable, which means that we need to predict if the person is going to buy our product or not looking at their age. So let's get into our Spider environment, the Python environment, and see how we can build this kind of model. Okay, so here I have all the libraries. So first I will import all the libraries which I might require for this session, and then I will import the dataset, sales dataset, and I will store it into a object called sales. And if I want to look at how this variable looks like, we have 467 observation and 2 columns, and if we open it, we can pretty much see it. If we want to see the column names, which we can use column.values function, and which will allow us to see the name of the variables that we have in our dataset. Next thing what we will do is build a linear regression model using our statmodels.api as SM. We will use OLS, which is ordinary least square function, and we will fit bought as our y and sm.addConstant and age as our x, where we have added the constant in the x, because as we know from the previous session, we need to add the constant before it. Then we will fit the model and we will see the summary of the model. Okay, so I have built the model, and if we look at the summary and if we look at the R square value, which is 0.84, 84% of R square value, I think it's not that bad, but it's good enough. So let's predict few value using this model that we have created. For example, if we have age value 4, what would be the output response if 0 or 1, if the person has purchased the product or not? And if we run this, we should be able to see the predicted value. Okay, here's something strange. The value that we are getting is negative 0.08. Well, if we look at our bought variable and if we run the value count, we can see that this bought variable has only two values, 0 and 1. Zeros are 262 and 1 is 205. What does this signify? The bought variable says if the person is going to buy, then the value should be 0. If the person is not going to buy, the value should be 1. And the model that we have built is based on the age of the person. So predicting using age 4, we are getting a strange value, but the value should have been 0 or 1. We wanted to know if the person's age is 4, is the person going to buy our product or not? But a strange output is not allowing us to interpret our result. We will also try to predict with a few other values, where I will say age is 105, if this person is going to purchase my product or not. And fair enough, the value is 2.02. So this is also out of the range. The output value which we were trying to look at was either 0 or 1, which would have allowed us to understand if the person is going to buy the product or not. There is something wrong with the linear regression, and that we can understand by visualizing our data. So I will create a scatter plot between my input and output variable, which is age versus the if the person has bought or not. And fair enough, if we see that according to the age, which is 0 to around 65, we have the output variable is only in 0 and 1. So either the value is 0 or the 1. We cannot make any prediction which are not 0 or 1. 0 means yes, if the person is interested in buying our product, and 1 means that the person is not interested in buying our product. And our regression line was something like this. So this is a straight regression line. And if we try to cover this upon the whole plot, we would be able to see that this is how our regression line is trying to predict the values for us. Just looking at this, we can understand, no, our regression line is not going through our point in our data set. So something exactly went wrong, and let's understand what went wrong. So the model that we built is not right, definitely. There are certain issues with the type of dependent variable, because the dependent variable which is bought is only between 0 and 1, which is not a continuous variable. So using the linear regression line, we cannot predict the values which are binary or class values. So why not linear? Looking at this data, we will try to understand it from scratch again. So we have variable age, and another variable is buy, which was denoted by BOUGST, bought. And bought 0 means yes, 1 means no. So if we try to fix any line or pass through the regression line like this, and looking at any possibility we imagine, it won't work. Linear regression line will get confused, but it won't give us any optimum result. There is no fitting curve over here. So we cannot use a linear regression line because the output is binary, 0 and 1. Few real life examples would be gaming or gambling, where we'll win or where we'll lose. Sales, if the person is going to buy our product or not buy. Marketing, if we are going to get a response from our client or no response from our client. For credit card and loans, which we can build a model which is going to predict if the person is going to default on their loan or not. In operations, attrition and retention rate we can find using these kind of models, and the websites where we can utilize these A/B testing model, where we would say if the person is going to click on that particular button or not. In fraud identification also, if the transaction or the credit card transaction which was run, was it a fraud transaction or it was a legitimate transaction. We can use this in the healthcare also, where if the person who got cancer or not, just looking at the models, X-ray or MRI images or the symptoms. These are the few real life examples that we can apply on logistic regression, where we have only binary outcomes.